From now onwards, we're going to talk about different kinds of logical operators available in propositional logic. There are 6 logical operators that we will focus on. The first one is called negation operator. Second one is conjunction. Third one is disjunction operator. Fourth one is exclusive OR. Fifth one is implication. And finally, we will talk about biconditional operator. In this lecture, we will focus on the first 3 operators, that is negation, conjunction and disjunction. Now let's talk about our first operator available in this list, that is negation operator. Let P be a proposition. Not P is called negation of P, which simply states that it is not the case that P. First of all, please note down that this is the symbol to represent the negation. Not P is called negation, and it simply means it is not the case that P. If P is true, then not P is false. And if P is false, then not P is true. It is as simple as that. Let's try consider one example. Let P be a proposition. Adam and Eve lived together for many years. Then how a not P would look like? It is not the case that Adam and Eve lived together for many years. As I already told you that what a negation really means. When we try to negate the particular proposition that is represented by P, we simply state that it is not the case that P. Here also we are negating this particular proposition. Adam and Eve lived together for many years, and the result of negation would be it is not the case that Adam and Eve lived together for many years. Or for the sake of simplicity, we can simply write like this way as well. Adam and Eve haven't lived together for many years. It is not always necessary that you should place it is not the case that in front of the preposition. You can write something else that goes with the meaning. For the sake of reference, I am providing the truth table for negation of P. When P is true, then not P means false. When P is false, not P is true. Simple. Now let's try to understand what is conjunction operator. Again, let P and Q be 2 propositions. Conjunction of P and Q is denoted by P and Q. This is the symbol for AND. Please note down, this is the symbol we are going to use for AND in propositional logic. When both P and Q are true, then only the compound preposition P and Q is true. Let's consider one example. 12 is divisible by 3 and 3 is a prime number. We already know that 12 is divisible by 3. This is correct. And 3 is a prime number. We also know that this is also correct. As this proposition is true and this one is also true, therefore true and true is equal to true, right? For the sake of reference, I am providing the truth table here. This is the case that we are considering over here in this example. True and true equals true, okay? Please note down one important point. Sometimes we use but instead of and. Like for example, 12 is divisible by 3, but 3 is a prime number. Here but is equivalent to and. Please note down this point. But and both are same in propositional logic. When you find out but in a statement, then it simply means and. Therefore, both the propositions need to be satisfied to make this particular compound proposition satisfied. Now let's consider our third operator in the list of logical operators, that is disjunction operator. Let P and Q be propositions. Disjunction of P and Q is denoted by P or Q. Please note down, disjunction means or, and this is the symbol we are going to use for disjunction. P or Q. When both P and Q are false, then only the compound proposition P or Q is false. For example, 16 minus 4 equals 10. This is false. We know that this particular proposition is false. Or 4 is an even number. 4 is an even number. This is correct. but this is false. This particular proposition is false and this one is true. Therefore, the final result would be true. Isn't that so? This is false, this is true. We know that when both P and Q are false, then only the compound proposition P or Q is false. This is the compound proposition. Suppose this is P and this is Q. As P is false, Q is true. Therefore, the result is finally true. Here is the truth table of disjunction for reference. In this example, P is false, Q is true. P is false, Q is true. Therefore, the final result would be true. Please note down. Okay friends, this is all about the three logical operators: negation, conjunction and disjunction. In the next lecture, we will cover the rest of the operators. Till then, have fun and keep practicing.